Hey, welcome. Today, we're diving into the world of rocks and minerals, but we're going to do it in a way I bet you've never seen before. To understand the massive, powerful forces that shape our planet, we're going to start with something small, something you probably have in a drawer right now.
I know, it sounds a little wild, but stick with me on this. This one simple idea, making rocks from old crayons, is actually the perfect way to wrap your head around the incredible processes that build our entire world over millions and millions of years.
Okay, so before you can make any rock, you need ingredients, right? In the real world, those ingredients are minerals. They are these naturally occurring ingredients, right? In the real world, those ingredients are minerals. They are these naturally occurring crystals, and they are the fundamental building blocks of every single rock. For our little experiment, these crayon shavings, they're going to be our minerals. So here's the key idea. Minerals are the ingredients, and the rock is the final dish, It's made from one or more of those minerals all smushed together. Just like our colorful crayon shavings are about to get stuck together to make our very own rock.
All right, let's get into it. Part 1, layer by layer. We're making a sedimentary rock. This is the kind that's formed from all sorts of particles settling down in, well, layers.
So, our crayon recipe is super simple. We take our colorful minerals, those shavings, and we just layer them up exactly like sediments of sand or mud would settle at the bottom of a lake. Then, we use a little warmth and pressure from our hands to press them all together.
And you know what? Our simple little crayon rock is a perfect model for what happens in the real world. Over millions of years, wind and water break down whole mountains into tiny pieces called sediments. They get dropped off in layers, and the immense pressure from everything piling up on top cements them into solid rock. And that's how you get these incredible, layered sandstone formations.
This is what's so cool about sedimentary rocks. They're like history books. Because they form layer by layer, they can trap things, like ancient plants or animal skeletons, preserving them as fossils. This piece of shale right here, it's literally a time capsule from an ancient seafloor. Amazing.
And you see these rocks everywhere. Sandstone makes up famous buildings like the Red Fort in Delhi. Limestone, well, that's basically just the compressed shells of countless ancient sea creatures. And shale, that gives us the stuff we use to make everyday bricks and cement. But hold on, the story doesn't stop there. What happens if we take our sedimentary rock and crank up the heat and pressure? Like, seriously. Well, we transform it into something totally new, a metamorphic rock.
The name really says it all. Metamorphosis just means to change. So in geology, when a rock like soft shale gets buried deep inside the earth, the intense heat and pressure basically cook it and squeeze it. It changes completely, turning into a much harder rock, like slate, the kind used for roof tiles.
And that incredible squeezing is what creates those beautiful wavy patterns you see in metamorphic rocks. The original flat layers get all folded and twisted, creating these stunning ribbon-like bands. I mean, this is the raw power of the earth made visible.
Okay, now for the final, and I'd say most dramatic transformation. We are taking our rock and turning up the heat all the way. We're about to create an igneous or fire rock.
For this last step, we melt our crayon rock completely down to a liquid. This colorful, waxy liquid is our magma, just like the molten rock found deep inside the earth. When this magma cools down and gets hard again, it forms an igneous rock. Every single igneous rock, no matter what it looks like, starts out this way.
But here's the thing, how that magma cools is everything. If it cools really slowly, deep underground, big, beautiful crystals have time to grow, creating a rock like granite. But if it erupts from a volcano as lava and cools super quickly in the air, you get a fine-grained rock like basalt, with tiny crystals you can barely see.
And that super fast cooling can lead to some really wild results. When lava cools so quickly that gas bubbles get trapped inside, it creates pumice. It is so full of air pockets that it's actually light enough to float on water. Think about that. It's the only rock that floats.
So there we have it. We've made 3 completely different kinds of rocks from one little pile of crayons. But what's the big picture here? Let's connect all the dots.
We went from sedimentary to metamorphic to igneous, kind of in a straight line, right? But in the real world, this whole process isn't a one-way street at all. It's a continuous, never-ending, powerful cycle. And this right here is the single most important takeaway.
any rock can become any other type of rock. An igneous rock can get worn down into sand and become a sedimentary rock can get buried and transformed into a metamorphic rock, and a metamorphic rock can melt into magma and become a new igneous rock. It's an endless, powerful recycling program.
And the results of this incredible cycle? They are literally all around us every single day. The granite on your kitchen counter, the marble of a statue, the graphite in your pencil, even the salt you put on your food. They are all rocks and minerals, and each one has its own incredible story.
So the next time you're outside and you pick up just some ordinary stone, take a closer look. Is it layered? Can you see little crystals? Does it have those ribbon-like bands? It's not just a rock, it's a piece of our planet's history, and now you have the tools to start reading its story. Thanks for joining me.